Cool, thanks for coming, everybody. If you're a little bit more comfortable and you feel a bit, feel free to move out the seats a little bit into the corners or whatever you want. Just get yourself nice and comfy. For those who haven't met me before, and there's some new faces, my name's Josh. I'm one of the organisers and founders of .NET Liverpool here. Nice to meet you too. He's a regular. Yeah, I can tell by the t-shirt, it doesn't work here. So we meet monthly. We're a .NET group. We've been going for 7 years now. We've been 2 years at this particular venue. We do everything .NET, and sometimes we do talks around business and other frameworks as well. Next month, I don't think I've published it yet, but we're going to be doing a talk for one of the directors at, I think it's Cinch, and he's going to come in and talk about technical architects and what he's looking at, the team structures, that sort of thing. So we're moving away from software a little bit more into architecture next month, and we alter it as well. Octobers and stuff like that, we do lightning talks. You might, if you've seen that, we get people up for like 10-15 minutes. So we alternate. We've also got newsletters that we go around keeping you up to date. This year, we're potentially looking at other venues as well. So there's a questionnaire going out on our newsletters that's critical around timing to try and make sure that you can all attend and best days that suit. We'd love to try and make it more inclusive. So if you've not, try and please the QR code that you've scanned, very important. We track your email, and we can send out a newsletter, keep you up to date. And we do that by ourselves, so not through Meetup. Thank you for everyone who scanned the QR codes. If you haven't, also very important, where we make this a community event, it's all free, but our funding the pizza, the drinks, the venues, all these costs and overheads that we do have, thanks to our sponsors. So the few questions that you do sign coming through the door not only enables us to keep running our meetups groups, but it helps us a lot. So thank you very much. So just to get on, it's a lot to pull this all together. So a big thank you to all my volunteers who are helping today. We've got someone new on the streaming software at the back, and we've got new people coming in through the doors all the time. So Rafi's new, so round of applause to Rafi at the back there for his first time on the streaming. But yeah, thanks to my volunteers. And if you do want to come and volunteer, we've got a lot going on, so just come and speak to me at the end. Again, these are our sponsors. So we've got SMA Academy. If you've gone through the QR code at the start and you've ticked the right boxes and it's relevant to you, we'll send you out some information. This is specifically relevant because they run courses on AI, and this is free. There's a brochure which I'll show you in a second, but these are basically funded apprenticeships, so like master degrees sort of equivalents, where you'd pay thousands of pounds to go to university. You can get that for free for a company's levy. It sounds more complicated than it is. If you do want to, you can reach out and they'll explain a little bit more about that. But it's a great way to upskill in AI, especially with their current AI and apprentice scheme. Apprenticeship sort of feels like, just out of university, like sort of, I want to get an apprenticeship. That is not what it is. I'm a .NET developer with over a decade of experience, and I would jump on one of these to sort of learn on the industry standards. Hyperloop, so if you know someone who's currently in the market for a job, or if your company is looking at hiring, reach out to them. They're a great support of this group, and we become strongly recommended from us as well. And Barclays Eagle Labs as well. I'm not going to talk much about Barclays Eagle Labs. We've got Ella, a representative from Barclays, who's going to give you a little bit of info on there right now.
Hello, I'm Ella, and I work for Avenue HQ. If you don't know what that is, it's the building you're in right now. So we offer memberships in private offices, and we also do community events such as this one, networking events, pop-ups, wellness events, and the occasional free spread. We are partnered with Eagle Labs. Lily unfortunately couldn't be here today. But Eagle Labs, if you don't know what that is, it's a partnership that we are involved in, and it offers support to new businesses and startups in Liverpool, and the base here. So any mentoring and one-to-ones are all free with the Avenue HQ membership. If you are interested in what we actually do here, I've got some free day passes, which I'm just going to put on that table, and you're welcome to take one and see what we do. Thank you.
Yes.
There you go.
Check that. Yes, I'll leave these on the side. So thank you all for that. Next, we've talked about Hyperloop, but if anyone was interested, QR code there, and we'll be scanning it around at the end as well. If you are interested in the academy, barcode there will give you a digital brochure for one of their courses around AI. So if anyone's interested there. And then you've all scanned the QR code. If you've ticked the last box saying you're interested, we're going to do a little raffle. We've got a little system at the end for those who are aware. And we'll be giving out 2 licenses today at the end of this event, both worth about £100. So you're getting to get them for free. So yeah, well worth doing. That's that. I'm not going to talk about the different products that they do. Just to all let you know that this is recorded. We're going to post some pictures on social media, so hopefully you're all okay with that. If you haven't, let us know if there's any pictures you don't want on there. I've got a bad side shot or anything like that, let me know. I'll take it off immediately. Don't want to upset anyone. Other than that, I'm going to pass you on to, I think it's Samson's going to set up first. Good luck, Samson.
Amazing.
You, mate.
Hello, everyone. Nice to see you all again, and some people for the first time. I'll just talk a bit about myself. Just like Josh said, I co-organized this. Been doing this for, I think, 2 odd years now. During the week, I work in automobile finance. And personally, best way to introduce myself, I'm a creative person, more in the enjoying creativity. I love to explore any sort of creativity at all, and how I basically experience creativity in my own way is through software. I enjoy systems, to be fair, and basically everything that goes with making them do my bidding, if you may say. So today, what we are here about is Agentic framework, Microsoft Agent framework. This is an SDK basically introduced by Microsoft in the .NET ecosystem that basically enables us implements agent-to-agent communication, basically orchestration or workflows for agentic applications. So basically, with one of these, you could be one of the people creating one of the fancy AI apps we see everywhere. What's agent? So before we talk about orchestrations, etc., what orchestration is or why we need to orchestrate, I like to go through things from a perspective of a why. So I'll talk about like traditional software products, where we have products that serve a purpose through very tightly bounded predetermined rules. So you have automations that say, do this, do that when condition A, B, and C are satisfied, or do this, do this. But agents sort of like take a different approach through this, where you have no rules, but rather less tightly bound rules. So you basically have there's still rules, there are still rules in the system, but they're less tightly bound to simulate a form of autonomy. Not autonomy in the sense of Jarvis or any supercomputer like that, but autonomy in the sense of we have accessible reasoning now, and that enables us to create applications without as tight rules as we normally would need to be able to complete any business process. And you'd say LLMs amazing. Why everyone has access to LLMs now? Maybe I could create an application, a software product. I have LLMs. That's very easy. Whip them up, connect them to this, and I have a software product. Unfortunately, no. Accessible LLM does not a software product make. And why is that? I'll give a very simple example. The most popular one, ChatGPT. You go on there, you send messages, you think in real time, it learns about you, you're communicating, takes context about what you're doing or your history, but no, it actually does not. The company behind that has context about what you're doing. The LLM doesn't learn about you in real time. You do have to coordinate other parts or other software systems to be able to enable any sort or any form of functionality. Same with long-lived processes, where you have processes or business functions that start day one, they might end 2 years later, depending on whatever termination condition or whatever happens. But this can all be processed autonomously. I keep saying autonomously in quotes because there's no such as autonomy at the moment, but yeah, this can all be processed autonomously. As well as something that's important for any software product, monitoring. Loads of reasons why you'd want to monitor your application, even if you're not interested in how the application is working. You're interested in the resources that are being used. You're interested in what is failing. You're interested in who has access to what or not. And something that way more important is security, because you lose money real quick for that, even if you don't lose money over monitoring. So yeah, diving into, 1 second, I went too fast there. There we go. Diving into the new kid on the block, Microsoft Agents Framework. This is a library, basically introduced by Microsoft. It was late 2025. Prior to that, we've had the semantic kernel, which was basically an SDK that enabled you do LLM embedding in applications. So basically the whole LLM client communication, you're able to like do that in applications. It was just basically an abstraction over that. And it really works well, really nice. To the whole, couple of you might have heard of like MCP. I think they had tooling around all of that. So basically with semantic kernel, you can do a lot of that. I don't think there's going to be much support for this going forward, just because of the agent framework. And I also talk about AutoGen. This is a whole lot less popular than semantic kernel was. This is actually really based on research. If you've ever done any long stringed prompting with an LLM where you're almost going insane over, oh no, this is what we're talking about, there's back and forth, iteration. Well, with AutoGen, you could actually have the LLMs drive each other crazy by giving in an input, creating very modular specific agents, or basically chats, LLMs that have specific context or instructions to be students, professionals, and have them interact over a question and arrive at a resolvable, acceptable result or solution for the user. And that's what AutoGen helps you do, which is actually pretty neat because it does a whole lot of like planning, reiteration, which is really nice. And then the new kid on the block who we are here for today, the Microsoft Agents Framework. This is a very nice set of tools, abstractions that enable a whole lot of things. So a whole lot of everything you've seen on this page and more. Monitoring, basically able to tack on to many things. You're able to tack on security as well because you're able to determine context or bounded scope between within which any agentic actions etc goes on to. So what I'll be going through today would be just some of the functionalities this library opens up, some of the options opens up to you. And I'll be starting with the first one, which is the structured output. And in my opinion, this is like the most important thing about this library. Helps this basically takes a whole lot of manual tacking on and orchestration into a few simple lines of code. So exit here and click on this real quick. I just want to show this. This is semantic kernel. This is trying to get a structured, or rather a contract between an agent where you get an input and you get an output. So any workflow, any system, it's input, output. Agents or LLMs, why are they very amazing for us? Because you go in free text and then you get output. But output is often free text, and free text input and free text output does not very good make for orchestration systems because you do need very strong contracts or boundaries between each of any services or any communication between services. So how did we solve that in semantic kernel? We did something very funny like this. You have to create very long, this is literally a literal string of a JSON representation of what the data structure should be. So this gets sent alongside your query or whatever input, and then gets deserialized into an object that should match the shape. You could imagine the hell it would be maintaining this maintaining this in any project whatsoever alongside any other project. Now let's compare that to this fella over here. Oh yeah. Let's take you out. I just want to highlight this line over here. That's actually POCO, a plain object, and that's an agent message, and that's the output. And all I've had to do was have a generic API or generic method that goes, oh, I need my result in this output. no instructions going in with, oh, I need you to give me extra details, make sure the instructions come back in this output. What does that enable me do? Whole lot of orchestration, get this out, I'm able to use the result to do any other loads of other things, and even pass that into the same agent with a different contract, although that might get very tricky because when you start giving instructions about you're an agent that does this and does that, the LLM becomes very confused about what it actually does. Hence the need for modularization. Second one, unfortunately, the clicker wouldn't be working here. Agents with tools. So the very popular thing we had last year were MCPs, where it was so exciting, where, oh, we're able to construct agents. We had reason, we have accessible reasoning, and we gave them capabilities. That's what autonomy is. Something has reasoning and it's able to perform actions both within the context of the system, outside the context of the system. And that's really amazing and also very dangerous because that's you saying, oh, your reasoning model, you're able to, you know you can do these things. Any contract, basically developing to contracts, you know you can do these things. These are the function capabilities you have. These are what I'm trying to achieve. Determine how best to do this. I don't want to, in real time, try to determine the sequence or flow of sequence to achieve at a result, but you're trying to achieve this result, these are your capabilities. Do your best. Let us explore together at how best you achieve this. Not very good because you're going to reach a state where you're achieving a lot of things that are not what you want to achieve, or exhausting resources, or a whole lot of things that could go wrong with free will, because we really don't want free will. The reason we are software engineers is because we don't like free will, we like automation. So one of the things the library gives us is the ability to interface with tools, with capabilities for agents. You're able to enable agents perform actions. So the entire MCP protocol becomes very easy as enabling an agent with tools, basically just giving the instructions or definitions of tools. So what does that do? It means with every single request or every single query you make to the LLM, alongside it is sent a deserialized, or sorry, a serialized object of the capabilities, description, name, etc, contract, whatnot. What does the agent do? It's from the context of the context it has, create either inputs to satisfy performing those actions when it needs them, or to achieve the goal. Again, this can get very tricky because you have a single agent that has access to, say, 100 tools to achieve a single thing, and then you have it trying to attempt actually making use of 50 of those or 20 of those to achieve same thing, or actually being stuck in a reiteration place where it's just trying to, oh, I have to try, even if it's failing, it keeps going until, yeah, you're in a very bad place. Also, something to keep mind of is token exhaustion, because very easily sending in that large schema with every request, LLMs are not cheap, except you have a lot of money. Next thing this library opens up us to, yeah, oh yeah, expanding. Next thing this library opens us up to, it would be, let me open this first. Would be agents as tools. So we already went through the part where agents have tools, but what if agents were also tools to other agents? What if we had a delegating or reasoning agent that decided, oh, just like we have AutoGen, where agents communicate with each other to arrive at a solution, it goes, oh, I do know experts on history, I know an expert in the weather, I know an expert in geography, and each of those agents could also have tools of their own or other agents that are tools of their own. So then you have a network basically of reasoning, where with a delegating or a top root agent that says, I have access to this, each root agent knows what they have access to. This, for one very important reason, reduces your token size for every request, because for every request that's sent, what is sent to the client or whatever LLM is a subset of the available tools or capabilities of whatever agent has been decided. for one reason, if no other thing, that's one very good reason that to use this particular API functionality. Really amazing. If there's no other reason, just reducing your token size is insane benefits. Last one would be the orchestration engine. So just like you have rule engines with workflows, you're able to decide the flow of this goes here in termination. Because of the structured output, again, one of the key building blocks of all this, you're able to decide the inflow, input, output contract, what each looks like, and where that part builds into or where that part leads into. You're able to go from A to B to C, basically design an entire workflow of orchestration, almost like a traditional software product, just with little points of reasoning where you decide direction loosely, not no decision at all, but literally decide directions loosely based on context. And in real time, you have options of paths to follow depending on output. Within that workflow, you're able to also add manual execution steps for any sort of like orchestration, not just LLM calls, because trying to run any business process through all directly through LLMs can go very wrong, very bad from experience, personal experience, very fast. Something else would be the multi-agent workflow orchestration. This is a very nifty set of tools. It lets you do agent-to-agent communication as well, but they are basically predefined communication routes where you're able to delegate the paths or the flow of the agent. So there's like the sequential one where every single agent in the pipeline have to go through a sequence to return to get to a result, or a parallel one where single agent has to take output to multiple agents at the same time, and those basically get converged at a different point, and then you get your output. Or a handoff one where you basically have tight rules as to who can hand off to who and who can basically where does input, what's the data flow, direction of data flow, very tightly you can decide. So this is no longer on a ad hoc basis where the agent decides I can go here or here. You basically say, oh, you only have access to this subset, and your response only goes back to this particular fella over here. And there's the one of the most important one. I haven't gotten into work, to be honest, but that's like the sickest thing I've seen, as the magnetic one. It's like a magnetic workflow where you have a delegating agent make a plan to get to a particular result. It makes a plan, tries to carry out that plan based on the functionalities and tools that it has access to, gets a result from the first iteration, decides on if it's reached an acceptable solution, and if it hasn't, it makes another plan, tries to get another result until maybe a maximum number of turns or any other termination signal you've set has been reached, or it reaches an acceptable output for you, which is really sick. Last one would be durable agents. So these are really basically tacking on agentic workflows, just like the ones I mentioned above, to durable functions. So durable functions is sort of like a Microsoft solution, it's an Azure solution where you're able to run serverless, you're running a serverless application, but you're running it over a long-lived context. So serverless applications, normally you have those run for like a couple of minutes max. We're able to like run long-lived serverless applications through these durable functions. State is mostly stored in blob storage, mostly blobs. State is mostly stored in blobs in between calls. You're able to basically have processes where you run, stop, start, based on signals, any startup signal, etc. And also, beautifully enough, you're able to do that with Microsoft Agent, tack that onto durable functions, and you have very long-living agentic workflows. I do not have a demo for this, but I have left a URL to the Microsoft URL to this at the end of this. I think I do have a bit of time, so I would go through a few of the agents I've talked about, the ones I have demo for. If Let's see how far I get with that. Dun, dun, dun. Oh, nice. This repository is available on the .NET GitHub as well. It should be on the QR code at the end of this. So just couple of nice little abstractions in there. Is this big enough, or do you guys want me to expand it a bit more? Expand it. Do I know the command to expand on this? Oh no. Maybe just, yeah. Yeah. Okay. Structured output bits. Beautiful thing about this fella again is this very amazing API here, the run async API. It's a generic API, generic method, lets you give in any form of inputs, get your response out in specific data structure. Something I've noticed from experience, you try to give so much instructions as to also the shape of the data as well as the generic inputs. You're not going to get very nice results of it. Second thing, you try to create a specific agent or LLM that has different functionalities. For this particular thing, I've tried to have an agent be knowledgeable about countries' flag colors and also the the code called again, ISO codes for countries. And then you go, oh, I need the flag colors for Portugal, and it tells you, oh, I only answer questions about Portugal because that was the instructions. I only answer questions about countries, and there's literally Portugal in the question. There, I need a flag about Portugal, and you can't answer that because you've basically given it three sort of like conflicting instructions, and that can happen very easily. And that's why we do the whole modular thing. Let's see this fella right here.
Does it add context of what the schema is to your prompt?
Yeah. Yeah, so basically for every single prompt, it adds, it serializes the shape of the schema, sends that along, and then it ensures that that's the response you get. So some fields might be null or not null, but that's literally the response you get. So basically, you could have an agent, and the only instruction is you are an expert in geography, and then you ask a question, and your only schema output is the basically maybe country name, it's about the country. You don't need to specify what it needs to return, or maybe a movie expert and you go, oh, what are the best 10 movies IMDb? Then you get both rating, date of release, etc. You don't have to specify all that, but it tries to fill in all of the properties within whatever schema you've put in there. Let's go. Yeah. It's going to be a little bit. 1 second. So this is a very simple instruction. I tried going earlier on with very crazy long list of instructions on, just like I said earlier, you answer questions about this, you do this, then this is your very strict rules about how you're going to respond or what you're going to respond. And that went really bad because very simple questions made me feel like I was literally talking to a chatbot, not an LLM. That was like really sick. So one thing to consider whenever creating instructions for models like this is very specific, short, simple. An experience that does help might be different experience with when you experiment with it. Second one are the agents with tools. I should have named this a bit better, to be fair, but I'll go with this instead. These are the agents are tools. There's like a very nifty factory static class that helps you create those. You're able to literally construct different agents. So you basically create different type of agents, and then you basically um, have an extension method that transforms them into tools that are basically appendable into a delegating agent. So you have maybe a delegating agent, say this is the delegating agent. Each of these are other agents that literally I've just created up within here. And I'm able to basically have them accessible to the root agent. Same way you create agent tools, to be fair, basically the contract description, name of what it does, basically helps give it context of what its capabilities are, on how it does that. I've basically done this in an MVC project just to demonstrate that you can also use dependency injection in this. So you're able to work within context, whether it's a scope for each session or request, you're able to like modularize within context, and you can also integrate this within your application without having to be a standalone console product or whatnot. Something also nifty to note is this chat client agent. So under the Microsoft Agents framework, there are loads of implementations or concrete classes of the AI agent. That's the root class. One of them is the chat client agent. That's the one that has access to the run async generic method. It's really nifty because it enables you to do stuff like add a context factory where within each call you're able to generate context from your environment. So one of the use cases I've used it for is within each call for a particular user, generate context based on history, append that to the instruction. So you're basically able to append context both before and after the call to the instruction. So you're able to either gain context, add it to the instruction after the call, either find out what needs to be updated about the context you had. So those are like three different LM calls in the process between that. So basically it's like a whole lot of like nifty control about like context, which is like really nice. With the executors, this is basically just like a rule engine where you are able to have determine an input and an output format and basically orchestrate that. Let me see where that is. This is a very, very bulky fun. This is a very bulky API, the orchestration that goes into this. It's a whole lot of like switches with paths where this goes, where that goes. This is like the output input. It's a bit not fun to work with if I'm being very honest, but yeah, it's a very bulky API. And then the last one we've just spoken about are the agent orchestration, but this is like with the handoff. So basically, this is basically you determining the workflow parts of this is a orchestrator agent or delegator agent. This has control and it has it's able to pass in context to the agents with location information and weather information. And these two agents can only send information back to the orchestrating agent, and the orchestrating agent can send information also to the translator agent. This basically sort of like maps out a pipeline as to information flow to arrive at a result. And I think that should be the last one of them. Most of the abstractions and whatnot for creating the agents I have in this repository. They would be in the final slides after here. So if you do want access to that, they would be on here. Apart from that, if you have any questions, very much welcome to them. Do we have questions? Yes, please. Okay, yeah, they do have a Python library as well. Yeah, so it's both Python and .NET at the moment. I don't think they have a support for JavaScript or any other language. TypeScript. Oh, that's nice. I didn't know that actually. You could do rags with them. So the entire idea, you definitely could do rags with them. The entire idea is there's loads of functionalities that enable you to embed them within your application. So within any enterprise application, whatever you're trying to do. So when I've spoken about like the context earlier on, the context factory, that's basically like the rag thingy where you're able to gain one of the things you could do is before the request, you're able to make the encoding and whatnot from your what's it called, your data storage for yeah, I forgot the term at the moment. Basically, embedded data.
Vectors.
Yeah, vectors. Basically, your vector database. You're able to like get that within call. So basically, you're not like orchestrating that. It's basically a factory that basically has context on how to do that. Append that to each call and then get the results back to you. So that's actually very nifty way of doing rags with that. Any other questions? Yes, please.
Functionality. Like, so you're setting up an agent with, I don't know, it might be JSON or YAML or something that has a set of instructions in it, maybe read sign in, rather than like doing it programmatically.
I don't believe it does at the moment. No, I think it's just programmatic at the moment. Yeah.
Thanks.
Yeah.
How much support do you think it's going to get? So that was ML.net.
So yeah, with Microsoft, it's a bit tricky. It's mostly about it depends on what they decide the company wants to focus on at the moment, to be honest. They've rock pulled on us a lot of times. So yeah, they have rock pulled on us a lot of times. So yeah, we can't really trust them. But so far, they really seem invested in this as they have in a lot of other things. So yeah, it's we'll see as fate takes us. Yes, it is. It's in preview at the moment. You can download it off NuGet as well, but it's in preview at the moment. So that's the APIs and methods are always they're receiving like really constant changes at the moment. So it's really, really in preview, not just decorated in preview at the moment. Yeah. Any other questions? Amazing. Thank you very much, everyone. Yeah.
Okay, just before I pass Julio on, do we feel like we need a break, 5-minute comfort break, or everyone all right to go on? This? What? Oh, are you doing it from this laptop?
No, my laptop.
Oh, right, okay.
Yeah.
Okay, cool.
But it's just I didn't have a slide deck, so he very kindly put my picture up there
Oh,
for everyone
nice.
to see.
Okay, so yours is
It's
awesome.
me. Hello.
Yeah. Right, okay, should we carry on? Should we go straight for it?
I'm okay with it.
Cool. Okay, we'll go straight for this one then. I guess one more thing with the agent framework as well, just before. There's loads of stuff Microsoft is supporting at the moment. So there's the Copilot SDK. You should go and have a look. What I'll also post is we want to get him coming over as well. There's Ramus. He's done a massive YouTube channel, probably about 40 odd videos on the subject. And the whole idea of this is if you're going to build a wrapper to an LLM, you're going to be writing more code. So go and have a play around with the framework. It's got really nice things in there to sort of trip you up. And Samson's done a really good job at demoing that. So pass you on.
The mic working? Because I don't know if we've used this one already. Yeah, all good. Okay. Hello, everybody. I'm going to give you guys a bit of an intro to myself if I step onto this side so I don't get blinded. This is my first time here, hopefully not the last, depending on how this goes. Well, I guess we'll judge it together. Just a bit of background about myself. So I came to the UK in 2016. I grew up in Belgium originally. I'm not a developer, so my background is, so I studied physics and did my BSc and my master's at Imperial. So I've worked in various different sort of roles in the data space, particularly around data science, machine learning, optimizations, and recently sort of converted into a bit more of a developer role as well with the whole AI craze and LLMs being able to translate from one language to another. I actually met Josh at work. We met about a year and a half ago now, I think. And a lot of what I do at work is actually programming in C# these days. So if that serves as testament to or as an invitation to try other programming languages that you might not have sort of wanted to dabble in the past, use me as an example, I guess. So after university, I spent some time as a data science researcher at Imperial as well, then moved on to a startup, a spin-out we did from the college. That lasted for about 2 years. And then, over to the dark side, consultant for private equity funds and their portfolio companies on all things data, so data warehousing, cloud, data science initiatives, again, optimizations. Worked very closely with technical teams more on the developer side of things as well. So started getting a bit more exposure to full stack and sort of cloud solutions, which, believe it or not, academia doesn't really teach you much about. And then, now I've been at this company called Health Partners. We're a leading UK healthcare company in the occupational health space. And I'm a data scientist and AI engineer. When I started, it was just me, and now we're growing the team to about 8, so must have done something right. But the talk I want to give today is a bit different, so I don't really want to delve too much into the code itself, because I feel like you guys all know how to program otherwise, or have a various degrees of experience, but at least know the fundamentals. So it's probably not as interesting to you if I show you yet another way of constructing an agent and adding instructions and attaching a tool to it. So my talk today is going to focus a bit more on when AI agents, or particularly LLMs, aren't fit for purpose, and what do we do then? Because a lot of the time you might be faced with a business stakeholder or a situation where someone wants you to build this new fancy, AI agentic system that can do whatever recommendations and filter data, I don't know, segment customers, and you might get to a point where your results are not super good, and what do you do then? So the example I'll go through today is hopefully going to evangelize you guys as to not using, or rather to not use LLMs to inspect, analyze, and generate recommendations based on tabular data, so numbers basically. So LLMs are not trained traditionally to deal with numbers, and we'll see hopefully very quickly how badly they perform compared to something super cheap, super easy to build, and much more traditional.
Sorry, I need to stream on this real sec.
Oh, okay.
2 seconds.
Yeah, go for it.
Some guys won't be a sec.
Come to name bookers. It's fine. Just let me know what you want me to type.
Talk instructions if you go to that website.
Okay. Your keyboard.
Talk instructions. Pause. And the S there. Sorry guys, I've not planned this very well. Still news. Streaming link, that one there. And then I will.
I should go share my screen, right?
Yeah. Thank you. Sorry about that.
All right. Hopefully everybody can see this. So I've built this little Streamlit app that is now decided to not run. So great. So this is the business problem we're faced. We're faced with a customer churn prediction problem. So let's assume that you're a company that receives tickets or emails from your customers, could be complaints, could be praise, you don't know what they are, and you're tasked by senior management to build some sort of system that can make sure customer retention is high, particularly for the telecommunications industry is the data set that we're going to work with today, where customer churn is very expensive, and most telecom companies lose 15 to 25% of the customers every year. As you might know, keeping a customer is a lot cheaper than acquiring a new customer, so you're actually, as a business, very much incentivized to spend a bit more money, potentially through discounts, to retain your customers. So this company, call it Telco Company 1, has got a data set, like most companies do, about the customers. So what kind of subscription they're on, how much they spend per year, how long that subscription will last, et cetera, et cetera. Most of it is it's stored in Excel or CSV or some sort of SQL database. It's mostly numbers, and it doesn't really have much qualitative information in there. So what's wrong with pure machine learning on that? Number one, if you get a ticket coming into your system or some sort of customer message, how do you go from that to something that you can do some sort of ML on? When do you to try and calculate what the risk of that customer is of churning? More importantly, how do you know if the query that's coming in is even negative, for example, or is something that even should necessitate something like a churn prediction model to be triggered? So what we're going to hopefully get to the bottom of today is why a combined system, so an agentic system, but that has traditional machine learning models, in this particular context, binary classifiers, excel, because you're basically leveraging your agent to deal with the request, the text information, and then decide through tools, which we've just described, that become machine learning models in themselves that you curate and build and can serve through MCP or whatever other technology you might like to use, excel at this task. So what I've done, well, if I scroll through, what we can see is in this particular problem, we're going to get some sort of natural language query that is coming in. we're going to need some sort of contextual reasoning, which is what reasoning models are good at. So, define in this case, we've broken it down to there's a technical issue, there's a pricing complaint, or it's just a loyal customer, someone giving praise, and we don't really need to action anything because they're low risk of leaving. This is something machine learning can't do very well. Traditionally, we'd have to go down the route of NLP, trying to break that down, trying to generate some sort of vector or embedding in the traditional sense, and then decide how we classify that into some sort of bins or buckets, which is something that we can now just leave to the agent. The agent just decides, based on what's coming in, what it needs to trigger. We just give them all these ML models as tools, essentially, and it can decide when it needs to trigger it and what kind of action needs to occur off the back of that. Also, traditional LLMs, well, not traditional, LLMs have the added advantage of communication and empathy. They can also then instantly translate those results into something that can be sent back to the user and hopefully get them to be happy with the response and stay on as a customer. So in this example, we might go through a few of the code examples later, but I really want to emphasize that it really doesn't matter what language you code this in. The backend for this is using vanilla GPT. We don't even need a framework. A lot of these big players in their APIs have tool execution parameters in their API calls. So you can literally, with JSON, is all we've done here, define what our tools are. Our logic in this case is hosted in the same backend in the server. That's where the functions get triggered. But that can be an MCP. That can be which is hosted in a serverless application like the one Samson was talking about that only gets triggered on consumption. So again, can be really done quite cheaply and done very neatly. So perfect combination, intelligent agents, something that can do both the calculation essentially through our ML models, but also can interact with our customers and perform all of the reasoning. There's a huge business impact here as well. If we were to just leave our LLM to perform the churn prediction calculation and give us some sort of probability outcome, if that probability outcome is over or underestimated, that can lead to additional, well, ideally if it's underestimated, always, that would actually make things cheaper, but you wouldn't retain as many customers, so then you would lose money on the back of it. But if it consistently overestimates the probability of a customer leaving, we might be issuing way too many discounts if we have some sort of tier discount system, which leads to a lot of leaked revenue, or rather additional costs. So for this one, we've defined for this particular example, a unified discount policy. Let's say that depending on the risk level of the customer, we're happy to issue a specific discount. Say our finance team has done the math on this, and this turns out to be profitable if run this way. So we have a duration for each of these discounts and a discount rate. The critical difference, as I was just highlighting, is that we could waste a lot more money if we had, these are actual numbers based on the example that I'll take you through in a second, where on a scale of 10,000 customers, we would have lost $870,000 additionally per year if we just leveraged OpenAI GPT to do all of our churn prediction for us. Oh, apologies, it's not big enough. I don't know if I can do. I mean, happy to zoom into sections later as well if there's questions. I think this is again, very much AI generated with my help, which will also be a testament to it. You could probably tell by all of the logos, but if we go through this, about 300 lines of code were enough to do all of this. We only have one simple agent loop. You can add whatever complexity you want on top of this. You can wrap this around, LangChain if you're programming in Python. You can use Microsoft AI SDKs if you're doing a C#. Framework I really like is Mastra. Don't know if anyone's come across it. It's the TypeScript framework for anything AI. Highly recommended. Also very much allows for all of this stuff to happen. So just quick background on the ML model that we've actually trained, because I think it's important. So our data set consists of 7,000 total customers. We have 21 attributes, which are our features, and we just want to perform a binary classification task, i.e. customer will churn or they won't. So it's a binary outcome. Our features include stuff like demographics, the services we provide to them, phone, internet, streaming, how long they've been with us, the contract type of billing, and then our target variable, which will be your churn, yes or no. So for anybody who cares a bit about ML, so the normal steps still go into this process. I'm just trying to highlight that you can't really cut corners on this. AI will help you, but you still need to deal with your data like you would in a traditional data science problem. So engineer your features, you need to one-hot encode. So this is for features that are that you need categorical to turn into categorical variables. So that's variables that either where you're modeling the occurrence of something, yes or no. So for example, someone has a phone with us, yes or no, et cetera, because you can't just pass the word phone to a model and hope for it to understand because it's not a number. The model architecture we're using here is what we call a voting classifier ensemble. So we use these three models: gradient boosting, logistic regression, and ADA boost. And our final prediction is a weighted average of what these three models score. And that brings us up to 80% accuracy on our test set. So I really wanted to, again, we split our training and test set 80-20, which is pretty standard. The thing I really want to drill down on here is that I actually went through the trouble of spending my own money on trying to use GPT to actually classify the same examples that I used on the test set with the traditional classifier model. It cost me about $10 to do, and the accuracy was only 40% versus 80% with the actual model. So they are a lot worse at doing this. And as we can see here, this is the comparison I did: 44.9% accuracy, $12.63 spent, 31 minutes training versus about less than 1 second to actually train this model. 7,000 rows is not even that big. So, you know, we can see that GPT-4 is even worse than randomly guessing if you put someone on this. So don't use it when you have lots of tabular data, because you're going to spend a lot of money, it's going to take you a lot of time, you're going to get a lot of errors, and you're going to be really unhappy. So hopefully, please listen to me. And the punchline is that, first of all, this is not a deep learning problem. A classifier will do normal sort of gradient boosting, random forest methods will do very well at this kind of data set size for this type of problem. And our ML model is the calculator. We want to really unlock the value of these intelligent systems by looking at the actual problem we have in front of us. Don't just throw AI at it and just say, okay, GPT-401, the newest, whatever, 01, the newest reasoning model is going to do amazingly well at this. No, it won't. It hasn't been trained to solve this particular type of problem. So actually look at what kind of data you have and decide what system should work best on it, and test it as well. And here we're going to go through a bit of a live demo. So I've picked 3 different examples of different risk levels for different costs. So 3 different customers with 3 different risk levels. We've got a high-risk customer, so our ML model rated this as 62.3% chance of churning, a medium risk 50.7%, and a low risk 10.5% problem. So here we'll see the customer profile. So this high-risk customer has been with us for only 1 month, being charged $36.45, month-to-month renewal contract. And our ML thinks, or our model thinks, this guy's going to churn. This person has written, I'm going to read it out loud because it's very small, doubt you guys can see it, but it says, I just signed up last month, but I'm already frustrated. The price is way higher than what I was quoted, and I keep getting charged for services I didn't ask for. This feels like a bait and switch. I'm canceling unless you fix this. So here, our loop, basically, our intelligent agent should, in theory, recognize that this is a pricing problem and should then invoke our churn prediction tool and then should issue a specific discount level based on the risk level of this customer. So we're just going to compare all 3 approaches. So if we just run the pure LLM loop, this is literally us asking the LLM to give us a probability or a risk for this person to leave and then therefore calculate a discount. So as we can see here, our LLM thinks 85% chance of churn, reasoning the customers express strong dissatisfaction, whatever, we can read through the whole text. So our LLM would have issued a 30% discount for 12 months, which would have cost us $131 basically, if we were to just use our AI or standard LLM for this. If we just run our pure ML, great, we have a probability, we have a prediction. What do we do with this? First of all, we would have had to figure out whether this is a pricing problem altogether, what kind of issue this is, how do we communicate this back to the customer now? We need to worry about standard email templating, loads of issues that we can fix by running our intelligent system, where our LLM is going to hopefully discern what kind of problem it is, call the right tools, and issue the right discount. This might take a second. There you go. So now we can see here the tools it's called. It's run our predict churn risk. It's run our guest customer profile and get customer history. I'll show you where these are defined in the code later because it's just JSON instructions that you can pass onto the OpenAI API. And then it's drafted an entire agent response, which we won't go through reading right now, because it's quite long, but look, it's issued 25% discount only for 9 months at a cost of $82. So the difference is quite stark, actually, in what we would have had to spend. And the probability, as we've seen by actually running our LLM on our test set versus our ML model, of actually the LLM getting that probability of churning right is lower. So in fact, it's just hallucinating these probabilities. You're oftentimes, when you force a large language model to give you something back because you want that, if it's not capable of doing so correctly, it's still going to do what you've asked it to and try its best guess, when in fact it actually doesn't have the right tools or the right training to actually give you the answer you need. I'll share the repo with you guys. You can run it by yourselves, but let's pick the low risk one. I appreciate this is going to be quite evident now that we've run the first one. Coin still stands here. This is giving us a 25% probability of churning, so quite a bit lower. This person's just saying they've been a loyal customer for 6 years. They've always been happy with the service, but they just noticed that their bill went up. So again, we have a pricing issue here. I think the medium one was the technical issue one anyways. But yeah, I would have issued an 8% discount for 2 months, and we run our intelligent agent on the same input. So again, it's literally just a string of text, and then our agent will decide whether it should call the churn prediction tool, whether it should calculate a discount based on it. Hopefully it's run it again. Yes, it's called our predict churn risk tool again, alongside our get customer profile and history to draft a better response as well. Again, why tool calling is useful, because it can gather all the additional context that might be needed. And then it's issued a 5% discount for 1 month, so we've saved money again by doing this. At scale, this is very powerful. I hope that point sort of has come across at this stage. The other thing I will note, though, is that oftentimes people will tell you, well, you're not using enough tools to solve your problem. I don't agree with that. Fundamentally, I think oftentimes you're just not using the right tools. I think giving agents less tools leads to better results than just giving agents too many tools. Why is that? We have something called tool fatigue, which is a documented problem, where agents tend to not look at tools that are defined later down the line in the script. So they tend to focus on the ones that are, it's called positional bias, the ones that are at the beginning. Also reasoning models, when you are trying to build really complicated loops where a lot of accurate tool calling is needed, it only takes one of those to fail for your entire thing to go wrong. So maybe your model is doing things very in a very correct reasoning sort of chain, but it's only failing in one particular spot, and it can sort of throw your entire system away. So again, a few powerful and correct tools can lead to much better results than a very complicated system where you might think you need to feed it all these additional context streams and new tools to solve a problem. I didn't think I would be done with this so quickly, if I'm going to be honest with you guys. I've talked very quickly. So maybe before I go into the code, I'm just going to see if I'm just going to pause here and just see what if there are any questions about any of this at this stage before I jump on to some of the repository maybe. Very good question. I'd say none of my job is traditional ML these days, barring maybe like 5% of it. So there are some projects, for example, we've been developing a pipeline to analyze different themes and topics from some of our admin inboxes. So we have a lot of, again, requests that come in from customers that our admin team sort of deals with manually, and we want to see what those main issues are, those main streams. So what we did was we embedded all of the data. We then ran a clustering algorithm on it to try and basically see if the data clustered into different themes. Then we sampled those themes, and again, using an agent at that point, we basically try to discern a theme from those clusters. So we go down the math route to actually detect the separations in the data, and then we use LLMs again so we use LLMs to embed traditional ML, and then LLMs again to basically make sense of the clusters. So that's, again, I hope that speaks sort of to the power of these hybrid systems, especially in day-to-day use. But that, I would argue, is a relatively sort of small side project that I've done at work. My main emphasis really is on clinical productivity. So how do we get doctors, it's context engineering at the end of the day. How do you make sure that you grab the right information for the right patient from the right case, that it doesn't sort of leak to an area where it shouldn't, and that those responses are also grounded and validated. Citations need to appear, etc., especially when you're dealing with medical information, which would be quite sensitive. One of the things that we've played around quite a bit with as well is the use of GraphQL as a way of getting agents access to your database, essentially, without them running straight away sort of SQL queries or operations or mutations on your database. And that's quite neat, actually, because through the use of JWT tokens, you can actually restrict the permissions of the agents, and based on who is triggering the flow as well within a tool, within the whatever platform you're in. So it's a blend of things. I think the best place to be in these days is to be able to have sort of a working knowledge of, I'd say, AI and systems engineering, enough software development that you understand what a back end, a front end is, and how they should communicate, and a bit of sort of security principles. And then, but also read a bit about data science and statistics, because it'll help you understand which LLM to use for which task, because you understand what has gone into the training process of it and what sort of the architecture is of a transformer, or how it works and why it's good for specific problems and what isn't. And it'll also allow you to, these models are easy to build. AI is very good at helping you build a classifier, and you're probably going to get by just understanding what it is and when you should use it, not needing to know every single detail about it. So I guess from my own experience, it's proven really useful to have a foundation in all three of them, with my spike being on the data science side of things, so that if you're in a small team, you can still push things forward by knowing all three. But then if you get into a bigger team, you can easily collaborate with the experts in each domain, because you know also kind of what they're doing at that point.
Data science, which division of software do you have data science? Do you prefer to hire a data scientist who's a software engineer, or software engineer to do data science?
I mean, I'm biased because I come from one specific area, so obviously I'm going to choose the same path that I sort of went through. But fundamentally, I know loads of people that did computer science at university, and they were never really exposed to this stuff, and then they pivoted and became some of the world's best quants, if you will. And then I have other friends that sort of started off more on the physics, big data analysis front, and are just full stack Java developers now. So I think actually it's just about sort of the will to learn these things, and I think it's also about finding the right setup for you, where you'll also get. I would hire someone, for the example you pick, I would hire a software engineer to also train them up in data science if I was in a company or a place that allowed for that. I think a lot of places you've got to be careful with. You're going to be boxed into what your title is, and there's going to be little room for you to actually explore and sort of push in other areas. So you're better off just doing your own thing or learning it first and then selling yourself as both. So that comes in as your sort of responsibility. Or find a place, there are also plenty, like the place I work at right now has given me the opportunity, for example, to write thousands of lines of .NET code, which is something I would have never been able to do if I hadn't gone to a place that had a bit more of that startup vibe. Let's build this team up from scratch.
Do you teach your physics student on a curve to solve computer science students obviously in physics?
Well,
none of this stuff works.
If you take a lot of if you were to interview a lot of people that studied physics, I wouldn't even call them physicists anymore, 5, 6, 7 years after they finished, if they haven't sort of kept up to date, they're not even going to remember how to, do some partial total derivative of whatever system anymore. That stuff you lose, right? So it's all muscles. Like, I think anybody that tells you can't learn something is just lying to you. You should say, no, it's all a muscle, right? It might take you a bit longer if you don't have the foundation, but I strongly believe that you can teach everybody sort of everything. And I think that especially if you apply the right method for the right person. And if they want to learn.
Thanks for the three discussions. How consistent are they in their response to you? Hey, when you keep them back.
Let's give it a go. I mean,
explainability, because obviously you no idea what they're doing, or maybe you do. Is there a which one would you prefer for explainability as well as consistency?
Okay, that's a very good question. Again, this is a demo I built literally in one afternoon, so it's going to have a lot of shortcomings, but there are great questions nonetheless. When it comes to general sort of LLM flows, you have telemetry built into like a lot of these frameworks now. You can use stuff like Brain Trust, Arise, or even Azure OpenAI. I think Foundry allows you to have observability built into it. So there you can see sort of the reasoning chains behind it, like how long it's spent on each problem, whether it's called a tool or not. I would definitely go down that route. But when it comes to traditional ML versus LLMs are non-deterministic. These models are more deterministic, and they're actually rules and sort of numbers based. So which at a lower degree, so it's a lot easier for you to potentially do something like a feature importance like analysis, where you could actually, we could take this classifier and look at from those 20 features that it's been trained on, which ones are the most, the most determining for the result it's given for that prediction. So to a business stakeholder, non-technical audience, you going and saying, actually, and don't quote me on this, but whatever, like gender and age plays the biggest role in like someone churning, is a much better answer than our models consistently saying it does so, like without it, you actually being able to mathematically sort of show like how much it does so, basically. Don't know if that fully explains the question, but if we look at the, I mean, let's run this one again on the low risk one and see what probability the LLM comes up with now. What we know for sure is that a model like a binary classifier, if we run it on the same data points over and over and over again, it's going to give the same exact response every single time, whereas our LLM might not. So here it's done 35% reasoning. I can't remember what it suggested. 25, there you go. It's already like hallucinated 10% more up and down. And the problem is that if we look at this, if we didn't know this was 10% and we go and read this, right? I've been a loyal customer, blah, blah, blah. I just noticed my bill went up by 10%. Can you help me understand what changed? And we look at this probability as humans. How do we judge this is wrong or right? Like we might, build validations into your, build observability into it. Make it explain its reasoning. Like, sure, you can build all of the infrastructure around it, but you're still left with all these uncertainties. And the moment it starts diverging from the same answer over and over again, oftentimes, I find myself in this situation as well at work where I'm just like, well, sorry, it's like I lower the temperature to 0, so I try to enforce as much determinism as possible. New models don't even have that anymore. Context engineering, limiting the right inputs. There is that, as Samson was saying, there is a lot of sort of variance in this that is very hard to sort of capture. So these are great at summarization like problems. So when it comes, look at Claude Code, like you can build an entire sort of hierarchical file system of markdown files that allow these models to traverse this perfectly and grab the right information with citations, attach them, etc. Amazing for that kind of work. The moment you try to predict the price of Bitcoin or whatever, you're left with quite a big issue. The funniest thing about all of this, though, is that transformers, if trained on numerical data or using whatever, mathematical concepts for their solvers or whatnot, can excel at numerical problems as well. So it's not that neural networks are not good at solving these kind of problems. It's just that the data we've given it and the rules we've taught it have nothing to do with the answer we're asking it from it. And when it comes to LLMs, obviously not if we just train our own neural network. Okay, appreciate we're almost at time. I honestly don't think there's much value in going through the code together or any of it. We'll push it up to the repository as well. Feel free to email me if anything is sort of not very clear. But again, it's beautifully simple. It doesn't even require and this is sort of the point, is that before you go into building using whatever library or whatever tool that it is you think you need, try to first break down the problem to sort of first principles. Look at the data that's coming in, look at the answer you want, try it with some vanilla implementation with APIs, validate it first, and then build complexity up from there. Don't think that, more complex system equals better results, because it's definitely not true, at least from my experience. Thank you. Thanks very much. Oh, sorry. Now we've got the raffle, right?
We have.
Yeah, just unplugged. I was eager to leave.
I've got good news.